everyone. I'm proud to introduce Francis Haugen and Patrick Phelps, who's going to be teaching us about Jupyter Notebooks in data-intensive communities. Give them a warm round of applause, please.
Good afternoon. My name is Francis Haugen, and this is Patrick Phelps. And we'll be introducing you today, or reintroducing you, to Jupyter/IPython Notebooks and how we use them at Yelp. I work as a data product manager on search and content understanding. What I think of as a data product manager is kind of a combination of a data scientist and a traditional product manager role. I worked at Google for 7.5 years, mostly on search applications, and now I helped co-found the photo quality team at Yelp and work on search UX.
And I'm Patrick. I'm a data scientist at Yelp. I've done a lot of work on our search team with how do we measure quality of search, and also how do we make tools so others can measure quality at search. I've also done a lot with our A/B testing framework, and especially with our traffic quality teams. So when people come to Yelp, are they a real human or are they a scraping program from some academic who wishes to learn more about businesses in America or across the world?
We're really excited to talk to you today about one of our favorite topics, which is data culture. So data culture is the set of practices, processes, and tools that a group of individuals uses to extract meaningful insights from data. And we think over the next 5 to 10 years, there's going to be a growing decentralization of data science skills throughout the software engineering community. And that means product managers who can productively extract insights and draw conclusions from data on their own. But that also means software engineers who can at least do a foundational level of data science and can draw conclusions that are accurate and useful and be able to communicate them to others. We also have a personal interest in this because both Patrick and I come from non-traditional backgrounds to software engineering. He has a PhD in physics, and I came in as an analog electrical engineer. And we believe that there is a big opportunity to bring in diverse talent into data science and software engineering through this path. And we actually give free tutorials to grad students. So if you know of grad students, or maybe your university, where you think people in the sciences would benefit from learning some data science, let us know. We actually are going to be going to a number of schools this fall.
So let's get to the meat of this talk. And to sort of set the stage for that, I'm going to tell you an honest fact, which is that data science is actually a very hard and difficult problem. And it's difficult for a lot of reasons. One, it's a very young field. So people aren't really sure what data scientists do. But it's also hard for a lot of logistical reasons. And I just want to go through a few of the big ones that make my job at Yelp a little bit harder. So the first thing you should understand is that data sources in reality are very opaque. You might, in your company, have a SQL data store or a NoSQL data store. You might have log files. You might have a Splunk dashboard. You might have all sorts of ways that data is logged in your company. And even in the best case scenario, let's suppose you had a SQL data store that had a very clear schema. You could use it very clearly. There was no ambiguity. Ambiguities still actually creep in. So for instance, in your data store, you might have a column called CTR, or click-through rate. And this seems great. You're going along one day and you're analyzing it. Everything's good. And then you notice it can be greater than 1. What does it mean for a rate to be greater than 1, you think? And that's because how you define even something as simple as click-through rate is actually ambiguous. There are different ways to define it. And the honest truth is that's the best case scenario. All organizations have history. All sorts of things happen. We migrate from one data store to another. We have things that go wrong. Oh, there was a bug in August. 2 days of internal traffic got routed as if it was external traffic, and it's in all the logs contaminating things. Don't forget to account for that. And so this is a really big problem. It's actually a very hard thing to know that you're catching all the common gotchas when you look at data. It actually turns out that's not the only problem. There's another problem, which is that spreading best practices in data science is not a trivial thing. A lot of times what we're doing is exploring unknown things. We're doing things no one at a company has ever done before. And what that means is people have different ideas how to do this, and you have to talk to them about how they do that. But also, things can get confused, and errors can go a long time without being detected. So it could be, weeks or months, and you determine that the way you are measuring something is done in 2 different ways by 2 different people in the company. And now you have to try and unify what you're doing. And the final sort of technical thing, the way people get around these first 2 problems, is they say, let's just write documentation. We'll just have tons of documentation. Everything will be perfect in the documentation. But let's be honest. Documentation is as much or more work than doing the original work. And what that means is, since we're all busy people, we say, oh, I'll do the documentation next week. And we mean it. But next week, there's a fire, right? Someone comes to us and says, oh my gosh, the app isn't working. What are we going to do? So you don't actually write the documentation. And even if you do, it tends to live away from the actual data source itself. And so you end up with things like, is this documentation up to date? Where was the documentation? Was it in our Slack channel? Was it on the wiki? Like, is it in my email? Was it in a postmortem report? Is it in a Google Doc? Where is the information? And all of these are logistical hurdles that really make data science hard. But even given those facts, there's something even more important.
Which is humans. Humans are really hard, right? We have emotions, we have communities, we have different ways of communicating. And fundamentally, data science is a communication activity. You went out there and you learned something. You had a hunch, you dug into the data, you found this insight, and now you want to share it with someone else. You want them to learn it too. Anytime you have communication, you have to know your audience, and you have to be able to speak the same language. The reality is our organizations are heterogeneous. We have people from lots of backgrounds. We have different levels of sophistication with data and fluency using it. And that can be really, really challenging. And one of the ways that one thing that can emerge is data cultures follow along a continuum of collaboration. The best data cultures are collaborative and collegial. People challenge each other. They ask questions. They contribute in lots of different ways to a single conclusion. And they go all the way to kind of magic data cultures, where you might have a hunch like, oh, I bet we could solve that with data, and then you throw it over the wall, and it lands in data science, and they poke around and they do things, and they throw it back over the wall to you, and you're like, oh, I have a conclusion. And if you want a really simple heuristic for the health of your data culture, ask, do we have a magic data culture? Does data science do things magically? And part of the reason why those things evolve is because data science requires a huge amount of trust. And I saw a Wired ad recently that said, data science is like a rock star. If you don't manage it, data is like a rock star. If you don't manage it carefully, it'll trash everything. And it shows this picture of a hotel room. That's really real, right? Like if you draw a wrong conclusion and you propagate that throughout an organization, people might invest millions of dollars in something that's not actually real. One of the things that can happen is we fall into these situations where the people who are the most fluent with the data, the people who live with it, who know all the things that can kind of go wrong, they know how you can make honest mistakes. And so when you start to have people throughout your organization trying to draw conclusions from data independently, they'll bring them to you, and you're left in this situation. Do you want to feel rude doubting them? Like, you know what the gotchas are. Are you going to interrogate them on every possible thing they could have done? Probably not. Like, people really feel uncomfortable being that level of confrontational. And so what usually happens is you end up just trusting specialists. You say, these are the people who have actually spent enough time with the data. They know the right thing to do. We're going to make a dashboard for everyone else. And if you want to learn something from the data, you should go to the dashboard, and the dashboard will teach you things. Oops.
And one of the things we want to tell you today is that these sort of choices, they seem really inconsequential, but they really do matter. Even the fact that you might say, we're going to build a dashboard, is changing who you are as an organization. It's changing who you're going to attract as talent. It's going to change how you draw conclusions for many years to come. Okay, so what is wrong with dashboards? I'm not saying they're always wrong, but what's wrong with them? What's the danger? And the basic answer is this. What you're asking is that some expert go out into the wild, and somehow they turn raw, messy data into sensible conclusions that anyone can look at and immediately know things. And in order to do that, they have to do what everyone has to do. They have to make assumptions. They have to say things like, well, I'm going to take the average, and that means something in this data. I'm going to only clean these sorts of ways. I'm going to present data in these sorts of views. And that seems great at first, but over time, what the dashboard encourages you to do is forget that those assumptions were ever made. And they also short-circuit the social aspect of data science. You often end up in this place where, oh, on Tuesday I looked at the dashboard and it said something, but then on Thursday I looked at the dashboard and it said something else. What's going on? Oh, I don't know. Did someone modify the dashboard? Is the data different? Has someone like changed what's going on? I can't actually link to what was seen in the past. Maybe I could take a screenshot, but those are hard to transmit around. And even worse, they actually make code review impossible. They make it impossible to like systematically discuss what you're doing. And I think like this is best summed up with maybe an example of a problem at Yelp. So your boss comes to you one day and they say, let's do a news article on the top 3 rated, or 3 of the top restaurants in Portland. And you think, okay, this is good. Like the Yelp, this is a very Yelp problem. Awesome, I'm gonna impress my boss. We have a dashboard. I'll go look at the dashboard. Cool, so you're looking at the dashboard, and the dashboard can answer this for you. This is very good. But as you're looking at it, one of the people who's been at the company quite a while walks by. And of course, they say the line that all people in all orgs dread. They say, oh, I hope you're not using that dashboard from 2008. Heaven forbid, no one knows what that thing does. And you're like, oh, crap. I have no idea right now what to do. Did the dashboard get updated? Is it sensible? Why is it still running? All of these are great questions, and you're trapped without an answer to any of them. And it turns out there's another solutional pattern that then develops. You say, okay, well, the dashboard can't solve all of our problems. Maybe it can solve some. Let's also use SQL and a spreadsheet, right? SQL and a spreadsheet. This is great. We're going to have someone write us some SQL queries. They'll output the data into Excel or maybe a Google sheet. And then we can share around the sheets. We can make plots off of them. Everyone is happy. And this seems really good at first. This is a sensible choice. You're doing this. Everything seems good. But then crisis strikes. And what is the crisis? It's almost inevitably your boss went into a meeting with your spreadsheet, and someone else's boss had a different spreadsheet. And they disagreed. And your boss came back and was like, oh my God, what happened? Why does my spreadsheet disagree with Samantha's spreadsheet? How did these get developed?
Don't they use data?
Yeah. If you're lucky, it's been 2 weeks. If you're unlucky, it's been a year. And the people who generated those spreadsheets are no longer in this company, right? They never documented what they did. Maybe even the data stores changed. And you're just out of luck. So what's important to remember here is that there are goals.
And the real goal that you were shooting for, either with the dashboard or with having a SQL data store, was data independence. You wanted to make it so that people can make decisions on their own using information. And you put the dashboard in because you wanted to, put some bounds on it, keep them safe. You put the SQL query, the SQL system there so that they could actually have some flexibility. But the thing that you actually want, the fundamental goal is around data independence. You want people to actually feel empowered to make decisions and to have the tools to make them effectively. We keep seeking for these Goldilocks tools, right? These ones that have such low barriers to entry, they're so easy to use that everyone in the organization can use them. But if we want people to actually be able to make nuanced observations or gain insights from the data, most of those tools that have the low barriers to entry also don't have runway. So we end up in this dilemma. Do we want something that's incredibly accessible or something that actually allows people to grow and become independent with data? And we believe there is a tool that kind of separates, that kind of finds an okay spot in between. It's not a Goldilocks tool. It's not automatically obvious to people, but it does give people that runway, and there's a lot of different ways that you can use it. So Jupyter Notebook is a computational environment that integrates both executing code with documentation and visualization. And it allows you to have everything in the same context so that analysis and the conclusions can all live together over time.
So now I'm going to tempt fate itself by trying to show you a live demo. So everyone, let us hope that this works. There's a good chance it won't, but perhaps the old gods and the new will be with us today. And I'm going to return to this basic question. How could we rank top restaurants in Portland? And this is a Jupyter Notebook. It's running in a live Jupyter Notebook server. We may also say IPython, because this is running Python. And it's important. I'm going to try and assume you don't know anything about these things right now. So the first thing to understand is very simple. These things have cells, okay? And cells run Python or some other language. And just like Python might normally, I can import modules. I just imported the time module. And what you saw is that little number on the side changed. That's when I ran it in the notebook. Jupyter Notebooks don't have the sense that like the top of the code is first. They have historical ordering based on when the user ran it, and they label that with numbers. Okay? Now, just like any piece of Python, I can write little bits of code. So here's a little bit of kind of useless code, but it prints out PyCon across the screen. That's cool, does it 10 times. But Jupyter Notebooks are cool because they actually do a little bit more. So one of the things they do is they allow you to have these blocks, which are called Markdown. And Markdown blocks are, in fact, code, right? They're like HTML code. You can have bold tags, you can do all sorts of header information, and much like the other code, you execute them. But they're meant to contain notes. They're meant to contain your ideas, your thought process. And that's not all Jupyter Notebook does. It does some other kind of cool things. So one of the things we've discovered is you can actually hack how Jupyter Notebook renders itself. This is really cool. So you can mess with what the HTML is that's rendering the page. And so you can create these HTML macros, which will actually allow you to do things when you are down the line messing with the page itself or viewing it. I'm not going to show you this right now. I'll show you it near the sort of end of the demo. So this is essentially, we're answering that top N question. So how many top restaurants in Portland. I'm going to just import some random code from our personal data repositories, but also like just common things like matplotlib. So here's like something you might obviously want to do in a data analysis. So it's a SQL query, right? This is would be against the Yelp data store. One of the things we like about Jupyter Notebook is that because these queries are being written by Python, you can actually have the Python help you write the SQL. So for instance, here I'm having the Python fill in this argument that I passed to the function alias. But you can actually do really interesting things. So like, for instance, if you know what a Wilson lower confidence bound is, it's really painful to write in SQL. You can do it. We've written a Python function that just does it, right? Like, it's do it once, never have to do it again. And you can test it. That's awesome. You can do pretty complicated stuff with these SQL queries. So, I mean, just 5-way join, have some things. So one of the things we talked about is, do you know if the assumptions in your data store were accounted for? If you're an experienced data store user and someone hands you one of these notebooks, you can just look and say like, oh good, they checked for, is the business expired, right? That's important. If it's expired, we don't want to actually have that in our accounts. And you can check the conditions themselves, and if they missed one of the common gotchas, you can ask the person just about that one and help them see why that's important. Okay. You can also obviously just write Python. Here I've written a bunch of it. I'm not going to actually go through that stuff. But now we can actually get to our question. So what I did was, as a data scientist, I'm often, I feel like people aggregate their data a little too soon. So I'm like, okay, let's just look at the raw data. So before I try and answer the question of what are the best restaurants, let's just look at the distribution of how many reviews the average business in Portland has. This is this plot. So up top here, this is the count of the number of businesses, and on the x-axis is how many reviews in that bucket, essentially. And what we see is that there's actually a huge spike here on this logarithmic scale, that most businesses only have a very small number of reviews. This is kind of expected, right? Like, it's very rare that a business will get thousands of reviews, but this does happen, even in Portland. And this is long-tail data. This is what the web is all about. And it challenges some of the assumptions people like to make and things they learned in their statistics class. So for instance, the mean of this data is about 20. The median is 3. Neither of those describes this distribution, because those are measures of what is called central tendency, and these sorts of distributions don't have centers. Okay? You cannot think in that sense of statistics. Statistics of central tendency fail when you talk about these sort of long-tail distributions. But you can get some intuition from them. So this is what's called a CDF. And what it tells me is what fraction of all businesses do I hit at some number of reviews. Okay, so what it tells me, for instance, is that about 85% of all businesses in Portland have 5 or fewer reviews. This might seem weird to care about this when I'm going to rank top restaurants, but it turns out that simple fact tells me that if I don't take care of what I'm doing, say for instance I just take the average rating, so everyone gives 1 to 5 stars and I just average those, everyone's who came, restaurants that have very few reviews will pop up to the top. Because if you're a restaurant and the first person who comes in is a really nice Portlandier, they give you a 5-star review, your average is 5. That's awesome. You are the top. No one can achieve a higher average, okay?
And there's a lot of subtleties with working with long-tail data, and we actually teach a whole workshop just on thinking in patterns like this because it's not obvious, and we didn't cover it in college.
Yeah, but if you have 1,000 reviews, so there's this restaurant that has 1,000 reviews, what's the chance that no one ever had a 4-star experience? I would say that probably someone did. Someone might have even given you a 1-star. People have bad days. Okay, this happens. We all do it. And so those people will never have an average of 5. So don't use the average. I want to illustrate this just a little bit more. So I'm going to take 3 of these restaurants, and these are links. You can link to outside web servers. These are all Yelp links. One of them has 100 reviews, one of them has over 1,800 reviews, and one of them is really new. It's opened about a month ago, and it has 8 reviews. So let's look. So first of all, you can just see raw data. I mean, you can do this. It's just a pandas data frame. Let's actually look at what would happen if I tried to rank those 3 using the average. So this is just using the average. And what I'm doing here is I'm replaying history. Okay? On the x-axis is the number of reviews over time, and the star rating, the average rating, is on the y-axis. So the soup cart has only received 5-star reviews, but it hasn't received very many of them. Okay? That's because it's new. It's doing well. And right now, if I were to say use this to rank, I would say the soup cart is a significantly better restaurant than something that has an average of about 4.6 stars and has 1,800 reviews. Okay? That's bad to do. People aren't happy. Well, the soup cart might be, but Tasty and Sons won't be. And now what I can do is what we actually want to do. And this is a relatively complicated model. It's a multinomial from 1 to 5 stars with a Dirichlet prior. It's sort of like unfair dice. And it's awesome that this is in Python because I can write this model in Python. I would love to meet the person out there who can tell me how to write a multinomial Dirichlet that needs Markov chain Monte Carlo in SQL. That would be epic. Like if you're in the audience,
Totally epic.
Come up after the stage. We are hiring. That would be amazing. But I bet there's not many people who can do that. So what's really important to remember here is that all of this is living together. Okay? So like people can see every last step of it. And if you're maybe your first one in your company who's trying to adopt this, they may not have a good way to share these yet, but you can always simply go and download them. Okay? You can download as HTML. And when you have the HTML, here it is. This is the HTML. And you'll notice something. No code is visible here. This just forms a note that shows people what you were thinking, what you were plotting, what you were trying to do. But look at that little button. If someone comes along and wonders, did you get that one gotcha in the data source? They can toggle on the code. They can go down. They can look at your query and say, oh, good, it's there. You check the expired date. So that's sort of like why we think Jupyter Notebooks are awesome.
They also act as an interesting platform for developing just one-off tools. So we've actually had a lot of success at Yelp around using IPython Notebooks to build custom things for people like community managers to find photos about their own cities that are in specific contexts, or our designers even. I made a notebook last week that accessed the raw and original photo downloads because the designers wanted to start experimenting with full bleed images. So suddenly they were now more self-sufficient because they could query the database themselves, they could tweak a couple little tiny things and be able to get what they wanted, and it didn't require me having to help them on each thing. At the same time, that example is a great illustration of one of the biggest problems with Jupyter Notebooks. So we've had an ongoing discussion at Yelp around the security implications of Jupyter Notebooks because, especially when you run them on a network server, you can end up giving access to that machine to someone who has access to the notebook. And there are protections built into Jupyter Notebooks to deter against this, but the default configurations don't have them. So you have to intentionally go in there and set the bits the right way to make sure that they're safe. But let's be honest here, if it's not in the default configuration, it doesn't always happen. Jupyter is also trying to push people towards using their enterprise servers to kind of address some of these concerns. And I think that could work really well for some applications. Patrick and I are kind of on a different opinion on it just because we do a lot of very computationally intense analyses. And when you have multiple people running on one box, all trying to do huge, many gigabyte things, it's just not a good thing. So we're a really big fan of running it locally, which kind of cuts the difference. The second issue is around reusability. IPython notebooks today are a little hard to code review. If any of you out there are looking for an open source project to work on, if you figured out a way that we could do code reviews on IPython notebooks, that would be amazing. Hint, hint. But there are third-party tools that can help you annotate HTML, and that's kind of the workaround that we've used so far. There is a real trade-off between ease of use and producing usable code, but we found that there is a project arc that works well, which is the first time you do something, you do it in an IPython notebook. If you find you actually reuse that analysis a number of times, maybe you'll productionize it into just a script. The last issue is verbosity. As you could see, one of the best parts about Jupyter Notebook is that the computation is right next to the conclusions. At the same time, that means you can have page after page after page after page of the execution of this analysis before you get to that last graph. Until we discovered the magic of the toggle, and it's magical enough that I included a bit.ly link, this was a really big problem. Like, it really hurt our ability to share conclusions. How Jupyter Notebooks fit into our work process at Yelp is at different phases in the evolution of a project. They're very, very important to us, at least on search and ads, during the exploratory analysis phase, but they're probably most important during the building consensus phase. So during that exploratory phase, you went out there and found a couple of, you had a couple of hints, a couple of maybe there's something there. But when you're in the phase where you're trying to build consensus, you want people to be able to kick the tires on your conclusions. Being able to share out these notebooks gives people the opportunity to actually go in there and, see if they actually are convinced. Maybe tweak it a little, maybe iterate back and forth with you. And then they also become important again during the analyzing experiments phase. We've found that IPython notebooks can be quite nice for standardizing processes and spreading best practices around, what are all the metrics you should be checking for this experiment? Especially in situations where you're going to access multiple teams' data stores, any individual might not know all the places they should be looking, but you can write a notebook once and share it out, and then everyone has access to that information.
And just an important point here, you'll notice not all the boxes are lit red. Jupyter Notebooks are not a panacea. They're not a silver bullet. They're not going to give you a data culture overnight, and Yelp still does build dashboards sometimes, right? We still sometimes use raw SQL. Those tools have their place as well. But what's important about Jupyter Notebooks is they provide a platform so that new people can read things that have been done in the past and actually have the right framework to ask questions about them and see what are the best practices.
You can also check them into repos. They can be treated just like other code. So in conclusion, like I mentioned at the beginning, we believe we're kind of at the threshold of a new phase in the computer science community where more and more software engineers are going to be expected to, at least be mildly fluent with data. And this is a great platform that, while it's not going to be your Goldilocks silver bullet kind of deal, it does give you a really nice platform for people at lots of different skill points, at lots of different backgrounds, to begin to become more data independent. And I don't think we have time for questions, maybe like one question.
Yeah.
Okay, go fight at the mic. But we will be outside afterwards for additional questions.
So we might have time for like one question.
Uh-oh. When they're running, this is going to be a good question.
Well, if no one else has a question. So I've really been impressed by the Jupyter Notebooks lately, and it strikes me that the competitor for Jupyter Notebooks is Excel, right? So with Excel, people are used to having a couple of hundred data points that are updated quarterly, which is just a different world versus an IPython notebook, you can have tens of thousands, millions of data points that you're analyzing. But in your experience, is this something that managers who would be comfortable using Excel can be made to be comfortable using Python, or they're just like, no, this is programming. I'm not a programmer. I'm just a manager. I'm just an Excel person.
So I think that's actually part of why Jupyter Notebooks are so powerful. So for any of you out there who work with, maybe you have a pointy-haired boss, that you want them to become more self-sufficient. You don't want to be pulling the data for them every time. You can make them a notebook once and say, I'm not going to pull that data for you anymore. I've made you a thing. You can do this. I've helped you install on your laptop. And one thing that's interesting about that is once they have that notebook, it might be that they're like, oh, that's all I need. Like, I can download it to CSV from my notebook directly. I can put it in Excel. That's all I need. But you've opened the door now. Like, if they want to tweak it, you can be like, oh, there's just one line you need to change. Why don't you try changing the SQL? And so it's a really nice gateway drug in terms of getting people who have never been, feeling very confident about data, beginning to do some of their own data analysis. We'll be outside.
So we're out of time for questions, but thank you very much, Francis and
Thanks.
Patrick.